All right, whether this is your first screencast or the umpteenth of many, it's good to have you back. We're going to be doing bivariate analysis today, looking at frequency tables of the type that you often see in publications. And what, in a nutshell, this is the kind of table that you see that might look at something like men versus women and the percentage of each category that, let's say, is Republican or Democrat. So these are contingency tables is the technical name for them. And what we're going to be doing with these contingency tables is trying to assess whether or not there's an association between the two types of variables that are being brought in. Again, this is bivariate analysis, meaning that you're looking at two variables at the same time. And the type of test that we're going to use to measure the association, it's going to be critical to know what type of variable you've got in front of you. Do you have a nominal variable, which is to say categories that have no logical order? And if it is a nominal variable, is it a dichotomous variable, in which case we'll use a different test than we use for nominal variables more generally? Is it an ordinal variable, which means that there's a natural sequence? Imagine runners coming in a race. One person may cross the line first, second and third may be clustered together, fourth may be off a little bit, and then fifth and sixth may be clustered, but there's a natural ordinal order to that. And then we have interval variables such as dollars or weather, where every 1 unit increase in the variable is assumed to be equal to any other 1 unit increase in the variable. All right, let's get ready to go now that you've had sort of the refresher on variables. This is a different data set than what I've looked at in some of the other analyses. So just to let you know very quickly, this is a cleaned up Pew data set that was administered in 2015, and that variable, or rather that survey, included a question that asked people whether or not they supported the use of torture against suspected terrorists in order to gain important information. And in the original wording of the question, people could say that it was 1, often justified, ranging down to 4, never justified. And I took that variable for the purposes of this exercise. I've coded into two dummy variable, or rather two dependent variables. The first is a supports torture dummy variable. In this case, if you said under any circumstances torture should be supported, you were coded 1, otherwise you were coded 0. In other words, 0 rejected torture all the time. And I also reverse coded the original variable to a 1 to 4 variable, this one right here, where 4 means that it's always justified and 1 means it's never justified. All right, so let's get down to work. We're going to go to Analyze, Descriptive Statistics, and Crosstabs. And you can tell that I played with that before, so we'll put that back. Really, we're going to put it back. All right, the standard protocol in SPSS is to put the dependent variable, that is the thing that you want to explain, in the rows column, and to put the independent variable, that is the thing that you think causes the outcome, into the columns row. So in this case, let's assume that gender possibly has effect on whether you support torture, and let's begin with the dummy variable. Because that's the dependent variable, I'm going to go ahead and move it over to the rows column, and we're going to go to the male respondent, and we're going to go ahead and pop that over to the columns. And now we want to go to cells. We need to look at our data first to make sure that it's clean. And because I want to compare males versus non-males, again, my independent variable looking for variation, how it impacts the dependent variable, because that's in the columns, I'm going to go ahead and check this column for percentages. I'm also going to take the observed counts, and I'll tell you why as soon as we get some results. Hit continue. And from here, I'm not going to paste because there's no reason to put this in a syntax. We're beyond recoding the variables, and now we're analyzing them. So hit OK, and let's get some results. As you can see, we have 1,462 people in the sample, and as I get down here to the cross tabulation, the reason why I want to put the count in the cell is all of the statistics that we're running, it's important that we have counts in each cell. So in this case, we've got women, we've got 199 who don't support torture, 467 that do support torture. Among males, that's 207 versus 589. If we had a 0 in there, we'd have to think about how we had coded torture, again, to make sure that every cell had a fairly large number of observations. Typically, the standard is more than 10. All right, we're taking a quick look at the data, and it looks like we've coded everything right. Among women, 29.9% said that they don't support torture. 70% did, at least under certain circumstances. The numbers are similar for males, but as I anticipated by labeling something a dependent and independent variable, we see that men are slightly more likely than women in order or to have this association between their gender. Let me rephrase that. Men are slightly more likely than women to say that they support torture. The question is, in the general population, is 4% a significant association? Who knows? Maybe that's due to random sampling error. So in order to determine that, we're going to have to do an associations test. We're going to pop back up here to Analyze. We're going to go back to Descriptive Statistics, back to Crosstabs, and you'll see that all of our information is right where we left it off, or left off with it. Only this time, we're going to pop over to Statistics. And I was playing this before, so I've got lambda checked. And let's talk really quickly about what we've got here. Because we've got a 2x2 cell, which is to say we've got men versus women, supports torture versus not supporting torture, we're going to use the phi test. If we had all nominal variables, for example, what religion are you and what party do you belong to, those are both nominal. There's no natural ordering to them. If that was the case, we would have checked lambda instead of phi. Again, we're doing phi because it's a 2x2. We would do lambda if it was a large number of categories by 2 or a large number of categories by a large number of categories. If we had an ordinal relationship, and I'll show you that in a second, if we had an ordinal variable and two ordinal variables and we didn't know what the relationship was between the two, we might check gamma, which is what you do when you've got two ordinal variables or you've got a dichotomous dependent variable and an ordinal variable together. If, on the other hand, you believe that there is a natural and logical connection between the two, which is to say that one causes the other, if you've got a clear dependent variable, then the test that you use is Somers D, and we'll get to that in a second. All right, we've got our 2x2 table, so we've checked Fiber and Kramer's V. Let's hit Continue. OK. And we get our relationship popping down here at the bottom. The phi test is really low. One way to think about this is typically if this was 0.1, so double the value that it is here, if it's 0.1, we might say that there was a weak relationship. If there's 0.2, we say also weak, probably, I guess below 0.1 is very weak, below 0.2 is weak. 0.2 to 0.4 it typically is considered to be a moderate relationship. Anything above 0.4 is a fairly strong relationship, which means that belonging to one category has a strong effect on whether or not you belong to the other. So this is a weak relationship. It is positive and not negative. These numbers range from -1 to 0 if there's a negative relationship, and 0 to +1 if there's a positive relationship. And what we see is a very, very, very modest association in a positive direction, meaning being male, corresponded slightly with support for torture in that 0-1 measure. We go over here to the significance. Ideally, we want a very low value here. If it's 0.000, that tells us that there's only 1 out of 1,000 chance that there's no relationship that we see over here. In this case, there's nearly a 10% chance that what we're seeing is due to sampling error. And that's not good enough. What we want is 0.05 or better, or rather below, in order to say there's a statistically significant relationship. So the way that I would interpret this is I would say the association value is very, very low and it is not statistically significant. Now, one possibility is because we've got this very, very strong category that says people who never ever support torture of terrorism suspects versus everybody else, it could be that if we measured that dependent variable a little bit differently, that we'd get different results. Lo and behold, I've done that. I created a dichotomous variable, but also that original ordinal variable. So let's go back to Analyze. And then we go to Descriptive Statistics, Crosstabs. We're going to change out that dependent variable, and we're going to put in that 1 to 4 ordinal measure, because I've changed the type of association that I'm using. Now I've got a dichotomous by an ordinal variable. I'm going to have to change the statistics that I'm using. So I go over to the statistics. We'll take off the phi and Kramer's V. Because I've got an ordinal variable, and because I assume that being male may have some type of positive association with whether or not you support torture of terrorism suspects, we're going to use Somers D. So nothing else has changed, just that one little thing right there. Hit continue, hit OK. And what we find this time when we look at the values, again, helpful, we've got no 0 cells up here, which means that we can go ahead and look down at the results. And here, if we treat supports torture as the dependent variable, we see that about 9% of the variation in who supports torture and who doesn't is in fact explained by gender. And this is a positive value, so we know that in this case being male is positively associated with supporting torture. And if we go over here, we've got a low significance. That's good, at least from a statistics standpoint. So what we can say is that there is a weak, certainly not a moderate and certainly not a strong, there's a weak association between being male and support for torture, and that is a statistically significant finding. So quickly to review, we're just about done here. I want to go back to the Analyze and Crosstabs just to show you what we would have done one more time if we had different variables. So we're at Crosstabs. We're going to take a quick look here at statistics. And going quickly through the options, chi-squared is the old traditional measure. All of these are developed afterwards, and to be honest, they're stronger. And so if you're looking at relationships, typically these are ones that you want to use. Lambda is what we would use if we did not have a 2x2 categorical variable. If we had, let's say, party, 3 categories, Democrat, Republican, other, and we had 3 religions, which is, I don't know, Catholic type of Protestantism and other. If we had a 3x3, we might well use lambda. And gamma and Somers D, I've already talked about that. They're both ordinal measurements, and you use Somers D if you think that you have a clear dependent variable. The last one that I want to mention is if you have a nominal variable, for example, partisanship, and you wanted to look at is there any relationship between, or rather association between partisanship and, so it's a three categories, let's say, again, Democrat, Republican, and other, by interval variable. How much money you made last year, that's an interval variable. Eta would be the appropriate measure. And in every single one of these cases, what you're going to get is the directional measure, which is going to tell you how strong is the association. Again, 0 to 1 is a positive, closer to 1 is stronger. 0 to -1 is a negative. The closer to -1, the stronger the negative relationship. And in each case, you're going to get some measure that tells you whether or not that's statistically significant or not. And that, my friends, is how you do contingency table analysis, which is one of the major ways that we do bivariate analysis.